guys, and welcome again to a very new tutorial. And from this tutorial we are going to start this journey of TensorFlow from basics to advanced. Today we are going to talk about a very core soul object of deep learning, and that is called as tensors. You will find these tensors everywhere spread around deep learning, from word embeddings to image tensors and so on. So what exactly are these tensors? How they are represented? We are going to study in this lecture. Okay, so let's get started. Now, a dot is simply a number in a Cartesian plane, right? Now, if we take multiple dots together, it will form an array, a line. Simply, if I merged different arrays together, I form a matrix or a square. If I keep on aggregating these squares, we get a cube, and if I keep on increasing the dimension, I get a sphere. Now here we see how it's transformed, right? So that's exactly what a tensor is. It's a generalization of scalar and vector to n dimension. Starting from a scalar, if I take 2, a single number, it's a rank 0 tensor because it doesn't have any dimension. What if I take multiple numbers, 1, 2, 3, 4, 5, all together, 1 cross 5, I have one dimension, so rank 1 tensor. That means simply taking 5 numbers together. We can also aggregate 2 arrays together to form a matrix, 2 cross 5, rank 2 tensor. So I guess you now getting the idea, right? We can also generalize this concept by taking an image. Now image is nothing but a rank 3 tensor. So let's define a rank 3 tensor of 3 cross 3 cross 3. Now what is this 3 cross 3 cross 3? It's simply height cross breadth cross channels. So we have height, we have breadth, we have channels. So imagine that we have an image of 3 cross 3, right? Where every pixel a value, it can take just 2 values. Let's say it can be either 0 or it can be either 1, a binary image, right? Let's also take an example. For example, we can have an image something like this: 0 1 0 0 0 0 1 1 1. 0 represents black, 1 represents white. So it's a black and white image or a binary image, for instance. So here we have simply just one matrix that simply represents an image of binary values. So we can also have a grayscale image where rather than having this 0 and 1, we take 0 to 255. That means every pixel can take 0 to 255, any one of the values. Then we have colored image, RGB, where we know that every pixel can be a colored pixel, and we also know that any color can be formed as some proportion of red plus some proportion of green plus some proportion of blue. And this proportion is represented by alpha 1 plus beta. If we combine all these together, then we get the color of that particular image, right? So, and that is the color of one pixel. So per pixel I have some value of red, some value of green, and some value of blue. So this also means that for every pixel I would have 3 values, or I would have 3 matrices per image, right? One matrix represent the red value of every pixel, one matrix represent the green value of every pixel, and one matrix represents the blue value of every pixel, right? Now if we concatenate these 3 matrices, and when I say concatenate in extremely simple terms, just put one matrix on top of another, like we saw that square getting transformed to cube, right? So that's what we can do here. Let's put one on top of another, something like this. If I try to create another square, please don't mind my drawing. I know it's not good, but I hope it gives you an idea as putting one value on top of another. So we have 3 values RGB. That's why we have 3 cross 3 matrices, right? So 3 cross 3 matrix, so it's a rank 3 tensor. I guess now you know why I said it's a rank 3 tensor, because we have 3 dimensions. So similarly we can also give this a higher dimension, more than 3 dimension, like you saw that cube getting transformed to a sphere, right? So let's visualize this much more better. If I create a maybe 3-dimension plane, something like this, right, x, y and z, and plot this cube here. Now if you see, this is an image, and for every pixel I have one green value, a blue value and a red value, and in a 3-dimensional plot it looks something like this, right? It's easy to visualize here. So if I maybe let's first of all put some dimension values here, like x, y and z. You can take other way around because it's homogeneous everywhere. Let's also put some dimensions here. This is say height, this is let's say breadth, and this is the depth, or also called as channels. Now this represents the red matrix, that means red value per pixel, right? Also this would represent the green value, that is green per pixel, and similarly we have this blue value that represents blue per pixel. So together we then combine it to form the red RGB image, or simply RGB image, not red RGB image. Now you got a bit an idea as in what tensors are. Now another question is, why do we need these tensors? So in deep learning and machine learning, especially in deep learning, we deal with the core fundamental algorithm is neural networks. Now let's first of all check this out, that what exactly a neural networks looks like. So neural networks, we have several different neurons. So like the edges that you see coming out, this is our first layer, right? Just 3 values, and you see that every neuron is connected to every other neuron in the network. As you keep on watching this, that how these connections are getting formed, and then this is the end neuron. So now the input gets transformed from left to right. So let's say this yellow represents the left, then orange, and then red gets transformed. So that's how input flows from left to right. Now let's also see some visualizations, some proper explanations. So this is the input layer. This is the input layer, and this is let's say hidden layer 1. So we just give it name as, because we don't see it in reality, so that's why it's hidden layer 1, hidden layer 2, and we have an output layer because this final neuron generates the output. Yeah. So in very simple terms, neural network is nothing but a function. So it takes some input, and you can imagine this neural network as a very big fx, which is a function, and it just takes an input, it does some magic inside, and it generates an output. So that's what a neural network is in extremely simple terms, a function. So this is like the connections that we see. This yellow are the connections, similarly is the orange as well as the red. So these are actually the connections between different neurons. From the left to right, then from right to the far right, that is the output neuron. So that's how the journey starts. We simply create from an input all the way towards the output. It keep on doing small functions together to get this final output value. So that's how it works. Now let's see something in practice, as in how we had that tensor, right? We had that matrix. So let's see how this input get filled into this neural network. So let's take a small example. Let's see, we have a rank 2 tensor, right? A matrix, and let's take these 2 values, 4 and 9. So we take these 4 and 9, we separate it out, and we then make it as the input layer. So these are now two values as the very left layer, and then we start creating the connections, right? And after start creating the connections, we simply pass them forward like we said. So that's how tensors are being exploited. So we store the information in the tensors, and then we one by one simply fetch the values, pass to the neural network, and it goes forward. Now, why did I take column wise? Why didn't I take row wise the values? It depends on you how you have arranged your data. Some people arrange it column wise, some people arrange it row wise. Here I've taken a column wise example, but that's how neural network works. So we take the input from the tensors. It would always be a tensor. If it's an image application or a language model application, it would always be a tensor. And just like this example, we take some values from the tensor and we pass it to the neural network to get a certain output. Okay, now let's understand another very important topic, that is called as axes. What are axes? Imagine that I have a rank 2 tensor of dimension 3 cross 4. So we have two axes, column axis and a row axis. So row axis and column axis, what it is, we can see this properly. So let's just suppose I want to do a sum over axis 0. Now after doing sum over axis 0, I get some values 15, 18, 21, 24. So the reduced dimension is now just 1 cross 4, because the output has just 4 numbers and it's just 1 row and 4 columns, so 1 cross 4. But how did it become sum over axis 0? I don't understand. So when I do sum over axis 0, it simply means just taking the first column, adding it up, taking the second column, adding it up, taking the third column, adding it up, and similarly fourth column. But why did I do fourth column, or why am I doing it column wise? In simple terms, it's because I said it's axis 0. So I had initial 3 cross 4. So when I say axis 0, that means I'm talking about the very first axis, right? Very first axis, that is 3. So I have to do sum. So in simple terms, axis simply represents the dimension along which you have to do the operation. So here this 3 would get reduced down to 1. So the output dimension should be now 1 cross 4. So when I say 1 cross 4, now I see I have 4 columns and 3 rows. So along which dimension, along which way should I do the sum so that I get 1 cross 4 as the output? The obvious answer is that since we have 4 columns, so I have to sum it column wise to get 4 values, right? So that's why it's 1 cross 4. So that's how sum over axis 0 means. Now that's what the simple idea is. The axis simply represents the dimension where the operation will get performed. So ideally it's also the dimension which will get squeezed, the axis that gets squeezed. Since I said 0th axis, so that's why 3 got squeezed to 1. Similarly, I can also have sum over axis 1. So now the second dimension would get to 1. That means 3 cross 1. Now ask yourself that why it's 3 cross 1? Well, I took the first row, added it up to get 10. I took the second row, added it up to get 26. I took the third row, added it up to get 42. So that's why I got 3 cross 1. Now you might again ask yourself why we have this 3 row, why we have this 3 here, not 1 there, right? So why it's 3 cross 1? Why 3 row? Because I said that we have to do squeeze on axis 1. So 3 cross 4 got to 3 cross 1. That means I need 3 values. How do I get 3 values? Since I have 3 rows, that's why I need to sum it over rows to get 3 values, right? So this is how you can understand the axis. So axes are nothing but simply the dimension along which we do the operation, and that dimension gets squeezed to 1. So that's what the access is all about. So I guess now you know what tensors are, the basic fundamentals, the basic foundation of tensors. So keep this small understanding in your mind, as in, okay, these are tensors, this is how they get input into a neural network. What are axes, how do we perform these values across the axes, what are tensors, and so on. So I guess this is it for this tutorial, and from next tutorial we will start from TensorFlow by creating these tensors in TensorFlow and applying several small operations to get a basic knowledge. So until next time, Radhe Radhe.